everyone, I welcome you all to this digital classroom for the subject control systems. Today we are going to solve few of the example problems which has been taken from the model question paper which has been released by VTU recently. Subjected to module 5 chapter 2 state space analysis. You can take down this question. A system is given by the following vector matrix equation given by x1 dot x2 dot is equal to 0, 1, minus 4, minus 5 into x1, x2 plus 0, 1 into u. Find phi of t. So you have been given with a vector matrix equation. x1 dot and x2 dot are the first derivative of the state variable x1 and x2. In this example, we have two state variables x1 and x2 and its first derivative is given by x1 dot and x2 dot. So you know to represent the standard form, x1, x dot bar is equal to a into x bar plus bu. So the matrix A is given here as 0, 1, minus 4, minus 5, which is a 2 cross 2 matrix. So you are given with a 2 cross 2 matrix. And we are supposed to find phi of t, that is nothing but the state transition matrix. The formula to find the state transition matrix phi of t is given by phi of t, which can be otherwise written as e to the power at, that is L inverse of Si minus A, the whole inverse. That is the inverse Laplace transform of S into I, where I represents the identity matrix minus A. Matrix A is given here in the question, the whole inverse, where L inverse of Si minus A, the whole inverse, in which Si minus A, the whole inverse is given by adjoint of Si minus A divided by determinant of Si minus A. So let us do this step by step. First, let us represent Si minus A. Si minus A, which is equal to S into I represents the identity matrix, and the size of the identity matrix will be same as that of the size of the matrix A. As the size of the matrix A is 2 cross 2, let me represent the identity matrix as 0, 1, 0, 1 of the same size 2 cross 2. Minus of matrix A is given by 0, 1, minus 4, minus 5. So I can simplify this as S 0, 0 S minus of 0, 1, minus 4, minus 5. So for the simplification, Si minus A is given by S minus 0. So the first term will be S, and 0 minus 1, you can write it as minus 1. And the second row first element will be 0 minus of minus 4. So it becomes plus 4. And finally, S minus minus 5. So I can write it as S plus 5. So we have found the value of Si minus A. We have represented Si minus A. Once after representing Si minus A, the next step is to find Si minus A, the whole inverse, where Si minus A, the whole inverse is given by adjoint of Si minus A divided by determinant of Si minus A. While finding the adjoint of a matrix Si minus A of order 2 cross 2, here we have Si minus A of order 2 cross 2, then we have to interchange the diagonal elements. We are supposed to interchange the diagonal elements, and we have to change the sign of the remaining element. I will repeat you once again. To find the adjoint of Si minus A of order 2 cross 2, as in this example, we have Si minus A of order 2 cross 2, we can interchange the diagonal element. So s plus 5 will be shifted to the first element and s will be shifted to the last position. And then we can change the sign of the remaining element. The remaining element are minus 1 and plus 4. So once after changing the sign, I can represent minus 1 as plus 1 and plus 4 as minus 4. So first, let us represent adjoint of Si minus A, which is given by, let us interchange the diagonal element. So S plus 5 and S, and change the sign of the rest of the element. Minus 1 replaced by plus 1 and plus 4 replaced by minus 4. So we have found for adjoint of Si minus A. And now let us find for determinant of Si minus A. Si minus A is given here. So the determinant of Si minus A is given by, let us cross multiply first, the diagonal element S into S plus 5 minus of minus 1 into the other diagonal element 4. So I can write it as S square plus 5 is plus 4. So I can simplify this as S square plus 4s plus S plus 4. So I can write it as S into S plus 4, taking S as common from the first two element and 1 is common in the last two element. I can write it as 1 into S plus 4. So for the simplification, I can write it as S plus 1 into S plus 4. So now I have found the determinant of Si minus A as well as the adjoint of Si minus A. So let us substitute for adjoint of Si minus A divided by determinant of Si minus A. So the next step is to represent adjoint of Si minus A divided by determinant of Si minus A, which is given by adjoint of minus A is here S plus 5 plus 1 minus 4 S, the whole divided by S plus 1 into S plus 4. So I can write it as, the numerator we have a matrix of 2 cross 2 divided by S plus 1 into S plus 4. So each element has to be divided by the denominator term S plus 1 into S plus 4. So I can write it as S plus 5 divided by S plus 1 into S plus 4, and the second element is 1 divided by S plus 1 into S plus 4, and the second row first element is minus 4 divided by S plus 1 into S plus 4, and the next element is S divided by S plus 1 into S plus 4. Once after finding adjoint of Si minus A divided by determinant of Si minus A, the next step is to take the inverse Laplace transform of adjoint of Si minus A divided by determinant of Si minus A. So the next step here is inverse Laplace transform of adjoint of Si minus A divided by determinant of Si minus A, which is given by inverse Laplace transform of the terms. Let me write it once again. S plus 5 divided by S plus 1 into S plus 4, 1 divided by S plus 1 into S plus 4, minus 4 divided by S plus 1 into S plus 4, and S divided by S plus 1 into S plus 4. I will repeat you once again, students. We are supposed to calculate for the state transition matrix phi of t, which is given by L inverse of Si minus A, the whole inverse. A is given in the question, the matrix A is given in the question, and I represents the identity matrix. So first let us represent Si minus A. We have represented Si minus A. Once after representing Si minus A, the next step is to find Si minus A, the whole inverse. To find Si minus A, the whole inverse, it is given by Si minus A, the whole inverse is given by adjoint of Si minus A divided by determinant of Si minus A. So adjoint of Si minus A is nothing but we have to interchange the diagonal element and change the sign of the rest of the element. I have done it here. And once after finding adjoint of Si minus A, we have to find the determinant of Si minus A. We have to find the determinant of Si minus A, which is seen here. So determinant, let us cross multiply the diagonal element S into S plus 5 minus of the other diagonal element minus 1 into minus 4. So once after simplification, we have obtained Si minus A as S plus 1 into S plus 4. Now we have substituted for adjoint of Si minus A divided by determinant of Si minus A by dividing the denominator term by each of the elements. Each of the element is divided by the denominator term, and finally we obtain this expression. Now we are going to find for the inverse Laplace transform of adjoint of Si minus A divided by determinant of Si minus A. So I have written here. So before applying inverse Laplace transform, we have to do partial fraction for each one of the element. And once after doing the partial fraction, then we can relate with the Laplace transform equality and take the inverse Laplace transform. And if you obtain the inverse Laplace transform of this function, that is nothing but we will obtain the state transition matrix phi of t. So the next step is to do partial fraction for each of the element. So I can write this as L inverse of S plus 5 divided by S plus 1 into S plus 4, and the second element is L inverse of 1 divided by S plus 1 into S plus 4. Then L inverse of minus 4 divided by S plus 1 into S plus 4, followed by L inverse of S divided by S plus 1 into S plus 4. And I can write it as phi 1 1, phi 1 2, phi 2 1 and phi 2 2. This is nothing but phi of t. Once after applying partial fraction and then taking the inverse Laplace transform of it, we can obtain the first row first element as phi 1 1, first row second element as phi 1 2, second row first element as phi 2 1, and second row second element as phi 2 2. And overall, I can say that the obtained matrix is nothing but the state transition matrix phi of t. In continuity with the previous sheet, first let us do with the partial fraction and then take inverse Laplace transform and find for phi 1 1. So we can write phi 1 1 is given by L inverse of S plus 5 divided by S plus 1 into S plus 4. We can do partial fraction, and we can represent it as S plus 5 divided by S plus 1 into S plus 4 can be written as A divided by S plus 1 plus B divided by S plus 4. Let us find for A and B. To find for A is given by the left hand side term. First let us write the left hand side term. S plus 5 divided by S plus 1 into S plus 4 into denominator of A. We have the denominator of A as S plus 1 at the solution for this equation. S plus 1 is equal to 0. So S will be equal to minus 1. So at S is equal to minus 1. S plus 1 and S plus 1 will get cancelled out. And let us substitute for S as minus 1. So minus 1 plus 5 divided by minus 1 plus 4 is given by 4 divided by 3. Hence A will be equal to 4 by 3. To find B, B is given by, write the left hand side term, s plus 5 divided by s plus 1 into s plus 4 multiplied by denominator of B here is s plus 4 at solution for s plus 4 is equal to 0. So s will be equal to minus 4. So at s is equal to minus 4. S plus 4 in the denominator and s plus 4 in the numerator will get cancelled out, and let us substitute for s is equal to minus 4. So minus 4 plus 5 divided by minus 4 plus 1, that is 1 divided by minus 3. So B is equal to minus 1 by 3, and we have obtained A is equal to 4 by 3. So let us substitute for A and B in this expression. So now s plus 5 divided by s plus 1 into s plus 4 can be written as 4 by 3. Substituting for A here, A is 4 by 3. 4 by 3 into s plus 1 minus B is 1 minus 1 by 3. So minus 1 by 3 into s plus 4. Now let us take inverse Laplace transform L inverse of s plus 5 divided by s plus 1 into s plus 4, and this is nothing but 511, which is given by 4 by 3 of L inverse of 1 by s plus 1. We know the Laplace transform equality. 1 by s plus a. The Laplace transform equality is given by e to the power of minus at. Therefore, 1 by s plus 1. A is 1 in this case. So, we get e to the power of minus t. Minus 1 by 3 of, in the second term we have 1 by s plus 4. In this case, a is 4. Therefore, I can write it as e to the power of minus 4t. So now we have obtained for 511. Similarly, we have to find for 512, 521 and 522. So 512 is given by L inverse of 1 divided by s plus 1 into s plus 4. So let us do partial fraction first. Do partial fraction. So I can write 1 by s plus 1 into s plus 4 as a by s plus 1 plus b by s plus 4. To find a is given by, first write the left hand side term, 1 by s plus 1 into s plus 4 multiplied by denominator of a is s plus 1 at s plus 1 is equal to 0. So therefore s will be equal to minus 1. S plus 1 and s plus 1 will get cancelled out. Substituting for s is minus 1. Minus 1 plus 4, I can write it as 1 by 3. So a is equal to 1 by 3. To find b is equal to 1 by s plus 1 into s plus 4 into denominator of b here is s plus 4 at s plus 4 is equal to 0. So s will be equal to minus 4. S plus 4 and s plus 4 will get cancelled out. Substitute for s is equal to minus 4 here. So 1 divided by minus 4 plus 1, that is minus 1 by 3. So in this case, b is equal to minus 1 by 3 and a is equal to 1 by 3. Once after obtaining for a and b, now let us find for 512, which is nothing but L inverse of 1 by s plus 1 into s plus 4. Now let us substitute for a as 1 by 3 into, we have here s plus 1 and b is minus 1 by 3 into s plus 4. Let us make use of the Laplace transform equality. 1 by s plus a implies e to the power minus at. In this case, it is of the form 1 by s plus 1 where a is 1. So I can write it as 1 by 3 into e to the power minus t. Similarly, minus 1 by 3 of 1 by s plus 4 can be written as e to the power minus 4t. So I can obtain phi 1, 2. Let us find for phi 2, 1 and phi 2, 2 following the same procedure. Similarly, I can write phi 2, 1 as L inverse of minus 4 divided by s plus 1 into s plus 4. Once after applying partial fraction, I obtain a as minus 4 by 3 and I have obtained for b as 4 by 3. And phi 2, 2, again let us follow the same procedure and find L inverse of s by s plus 1 into s plus 4, first by doing partial fraction. Once after doing partial fraction, now we have found the expression for a as minus 1 by 3 and b as 4 by 3. Therefore, phi 2, 1 will be equal to L inverse of, let us substitute for a as minus 4 by 3 and b as 4 by 3. And let us take inverse Laplace transform, making use of the Laplace transform equality. 1 by s plus a implies e to the power minus at. In this case, a is equal to 1. So I can write it as minus 4 by 3 into e to the power minus t. And 1 by s plus 4's inverse Laplace transform is given by e to the power minus 4t. And phi 2, 2 can be written as L inverse of a is given here as, substitute for a here. A is minus 1 by 3, substitute it here. And b is 4 by 3, can be substituted here. Minus 1 by 3 and 4 by 3 has been substituted for. Once after substituting for a and b, let us take inverse Laplace transform, making use of the Laplace transform equality. Hence, phi 2, 2 will be equal to minus 1 by 3 into e to the power minus t plus 4 by 3 into e to the power minus 4t. Now we have obtained the expression for phi 1, 1, phi 1, 2, phi 2, 1 and phi 2, 2. Hence, finally I can write the state transition matrices phi 1, 1, phi 1, 2, phi 2, 1 and phi 2, 2, in which phi 1, 1 is given by, we have found for phi 1, 1 already, in which phi 1, 1 is given by 4 by 3 into e to the power minus t minus 1 by 3 into e to the power minus 4t. Let me write it here. 4 divided by 3 into e to the power minus t minus 1 by 3 into e to the power minus 4t. And we have obtained phi 1, 2 as 1 by 3 into e to the power minus t minus 1 by 3 into e to the power minus 4t. So let me write it here as 1 by 3 into e to the power minus t minus 1 by 3 into e to the power minus 4t. And now we have obtained for phi 2, 1 and phi 2, 2. Let me copy paste here. Minus 4 by 3 into e to the power minus t plus 4 by 3 into e to the power minus 4t. And we have phi 2, 2 as minus 1 by 3 into e to the power minus t plus 4 by 3 into e to the power minus 4t. Hence now we have obtained the state transition matrix phi of t. In the next lecture, let us solve few more example problems related to state space analysis. Thank you.